Ready. So welcome to UV Physics Academy, and this is the bridge course of mathematics for CSIR net coaching, and today we are going to discuss this integrations. This is a very important, and here we are going to start the first one, indefinite integrals. What is meant by indefinite integral? Now here let us suppose there exists a function capital F of x. This is antiderivative. This is, let us suppose it is a antiderivative of some function, some other function, antiderivative of f of x. What is this antiderivative? For the time being, let us suppose here we have antiderivative. Just represent this operator with d by dx inverse f of x. And this is the capital F of x, that means f of x is the antiderivative of small f of x. Okay, that means we can rewrite this. This is nothing but capital F dash of x equal to f of x. Means again if you differentiate on both sides, you will get d by dx of f of x. Capital F of x is nothing but small f of x. That's good. So we can say like this. So what does it mean? This means here we have capital F of x, so we can say capital F of x is the antiderivative of small f of x, is antiderivative of small f of x. That's good. Let us take a few examples here. Now here I am taking x square, and what is the derivative of x square? It's a 2x. Again I am taking x square plus 1 derivative. This is also 2x. And let us change the function. X square plus 2 derivative. Again it is 2x. Okay. So here you have taken f dash of x equal to small f of x. So x square derivative is 2x. That means what? X square is the antiderivative of 2x. X square plus 1 is the antiderivative of 2x. X square plus 2 is the antiderivative of 2x. So we have a set of antiderivatives of 2x. So whatever the function we have taken, this 2x contains a set of antiderivatives. Okay. So if you take that set of antiderivatives, if you see, that is x square, comma x square plus 1, x square plus 2, so on. All these are the antiderivatives of 2x. So here we are defining an indefinite integral. So that means I am taking integral this 2x dx. So this implies what? This is equal to x square plus c. See, this x square plus c, that means x square plus 1, x square plus 2, so on. That means what this integral 2x dx is giving? 2x is a function that is called integrand. So what is this integral is giving you? Integral 2x dx is giving a set of antiderivatives of the given function, a set of antiderivatives of the integrand. So indefinite integral means this is nothing but indefinite integral. So indefinite integral means this is nothing but a set of, this will give you a set of all antiderivatives of 2x. Okay, set of all antiderivatives of 2x is nothing but indefinite integral 2x dx. So final conclusion. So what is this indefinite integral? The indefinite integral is defined as integral f of x dx, which can be written as this is we can say capital F of x plus c. So this is called indefinite integral. That means here integral f of x dx means that represent set of all antiderivatives of small f of x, which is nothing but capital F of x. So is it clear? So this is a indefinite integral definition. Please write down. So finally, we understood what is this indefinite integral. So indefinite integral of any function, it's a simply a set of antiderivatives of that function, a set of antiderivatives of the given integrand or given function. Good. Now, let us. So finally here we can say the indefinite integral, it's a simply integral f of x dx. So what does it mean? It's a simply a set of all antiderivatives, a set of all antiderivatives of a given function, that function integrand. So that one we are defining as some f of x plus c. So these are the basic formulae. So the first one, integral x power n dx is x power n plus 1 by n plus 1 plus c. Of course, c is some constant. And here n should not be equal to minus 1. If n is equal to minus 1, it will be diverged. So that's why it should not be, n should not be equal to minus 1. And if you take the reverse, we already explained that is an anti-derivative. So that's why if you apply a derivative on both sides, that is a d by dx, x power n plus 1 by n, this is n plus 1. This is n plus 1. X power n plus 1 by n plus 1 is nothing but x power n. Next, integral sin kx dx is minus cos kx by k. Actually, again if you differentiate this, cos kx differentiation is minus k sin kx. So that k gets cancelled and a minus of minus will become plus. That's again you will get back to sin kx. I hope you understand. In the differentiation, if any some constant into x is there, some constant into variable, then we will write that constant as a coefficient. Okay, but in the integration we have to write that in the denominator. In the differentiation we will write in the numerator, and in the integration we have to write in the denominator. The same, integral cos kx is a sin kx by k. And next, integral secant square x dx tan x plus c, integral cosecant square x dx minus cot x, and integral secant x tan x is secant x plus c, some constant. Integral cosecant x into cot x dx is minus cosecant x plus c. So please practice these basic problems, basic formulae. Now let us see some basic questions here. So before going to start this, let me have these rules. Whenever you have integral some constant into f of x dx, then simply you can write this constant k outside, integral f of x dx, no issue. And whenever you have two functions like this, plus or minus, then you can write integral f of x dx, you can split it, plus or minus integral g of x dx. You can split that to two functions. And whenever you have a product of this, unfortunately this is not equal to integral f of x dx, integral g of x dx. Here we have to use a product rule. Okay, this is not equal. Whenever a constant is there, you can write outside. Whenever plus or minus is there, you can split. But whenever a product is there, we cannot split like this. And this also definitely not equal to numerator integration by a denominator integration. It is not possible. G of x dx. These two are not correct. And whenever you have integral f dash of x dx, so that means this is the antiderivative, and again here derivative we already understood. So integral is nothing but the antiderivative operator. So antiderivative and a derivative. So definitely you must get f of x. Okay. So I hope you know all these things. Next one, let us do a few questions basic depend upon the basic formulae. Now here we have so t power 4 minus t cube plus t square minus 1 dt. So just to split it, if you know already, just pause the video and do it yourself. Minus integral, so the rule number 2, because you know whenever a plus or minus is there, you just split it, dt, of course this is also dt, plus integral t square dt and minus integral 1 dt. So t power 4, you know t power 4 means x power n integral, x power n plus 1 by n plus 1, that's why t power 5 by 5, and this is a t power 4 by 4, and this is a plus t cube by 3 minus here nothing is there means t power 0 you can take, so t power 0 plus 1 by 1, that is a t, of course constant plus c. And similarly here this also you can do, come on make it fast, integral 6x power 5 dx, split it, minus 18x square dx plus integral 7 dx. Just do it yourself. This is a 6 as usual, x power 6 by 6 minus 18, this is x cube by 3 plus 7 as it is. If nothing is there, that means 1 integral 1 dx, you can take it as x plus constant c. If you want you can cancel this, okay, if you want you can cancel this also. And the next here trigonometric functions are there, so please split it, integral sin x dx plus 10 outside, constant outside, rule number 1, constant outside, integral cosecant square x dx. So let us do this integral. Integral sin x is minus cos x, okay, plus 10 as usual, but cosecant square x is a minus cot x, just now we have seen the formula, please practice, please by heart, plus c, that's it. Next here you have integral 12 plus cos theta into sin theta plus cosecant theta into sin theta plus cosecant theta d theta. Just split it. So here also we have to split this because this entire thing, I think there is a bracket here. So integral 12 d theta, just to split each and every term. Cosecant theta into sin theta is 1 d theta plus cosec theta into cosec theta, that is integral cosecant square theta d theta. So if you integrate this, so here 12 theta plus 1 theta, and this is minus cot theta plus c, integration constant. So finally we can say 13 theta minus cot theta plus c, some integration constant. And here we have the next one, integral root x plus 1 by root x dx. Just pause the video and do it yourself, and after that check the answers. First rewrite this integral, let me write it as x power 1 by 2 dx. First split it, integral, this is 1 by root x, that's why I am taking x power minus 1 by 2 dx. Okay, so now same formula as usual, x power n, so n should not be minus 1, n can be minus half, no issue. Okay, so this is x power n plus 1, that is a 3 by 2 by 3 by 2, that's why it is a 2 by 3 plus, and this is x power minus 1 by 2 plus 1, that is 1 by 2 by 1 by 2, that's why into 2. I hope you got it. So please check your answers. Ready. So I hope you have verified your answers, and next one, sometimes very frequently we will use integral sine square x, integral cos square x in a quantum mechanics. Okay, so let us take this integrals. Now here I am taking integral sine square x dx. How to do this? So similar to differentiation we cannot take here. Earlier whenever you are differentiating sine square x, what you have taken? You have taken sine square x. This is a something square. Something square differentiation is what? 2 into something, and again something you have differentiated. Here it's not possible. Here it is not like that. Of course a substitution method will be there. That is a different one that I will explain. Just wait. So here we can't apply such type of things. Integral sine square x. Whenever you have sine square, cos square, something is there, then you have to use the trigonometric functions. Here we have some trigonometric functions. Cos 2x equal to 1 minus 2 sine square x. I hope you know cos 2x is cos square x minus a sine square x. If everything convert into sine square x, then it will be 1 minus 2 sine square x. I hope you know this. If anybody forgot, cos 2x is nothing but cos square x minus sine square x. And if you convert this cos square into sine square, it will be 1 minus 2 sine square x. So that's it. So from this expression, first you please take what is a 2 sine square x. So 2 sine square x equal to 1 minus cos 2x, and you can bring this to this side. So you can write sine square x equal to 1 minus cos 2x by 2. First please convert a sine square function into like this, integral 1 minus cos 2x whole divided by 2 into dx. Then after that apply the rule, that is a plus or minus rule. Just split it, integral 1 by 2 dx minus 1 by 2 I can write outside, integral cos 2x dx. So already we have explained, this is a 1 by 2, integral dx is x, and of course here it is a minus 1 by 2 outside, and cos 2x integral is a sine 2x by 2. That's why this is a sine 2x by 2. Of course plus 1 plus c, some constant. Finally x by 2 minus 1 by 4 sine 2x plus c. Now similarly let us take the second one. So please go through this. And the second one you please try. Just pause the video and try yourself. Please try yourself. And the second one I am taking integral cos square x dx. By using the same formula, please convert everything into cos square. That's why cos 2x can be written as, if you convert sine square into cos square, that will be 2 cos square x minus 1. Trigonometric relations. So that's why we can write this cos square x as same cos 2x equal to cos square x minus 1. Sorry, 2 cos square x minus 1. So finally cos square x is equal to, so this 1 you can bring this side, 1 plus cos 2x by 2. Okay, whenever you have sine square x, replace with the 1 minus cos 2x by 2, and cos square x you have 1 plus cos 2x by 2. So whether plus or minus or, if you have any confusion, so cos is a even function, write plus, and sine is a odd function, write minus. Just a small thing. Sine square x, sine even, sine square even, sine even, 1 minus cos 2x by 2. Cos square x, cos is even, sine is odd. Sine square x, sine is odd function. That's why 1 minus cos 2x by 2, and cos square x, cos is a even function. So 1 plus cos 2x by 2. Just remember like that. You take it and substitute, integral 1 plus cos 2x by 2 into dx. Split it, 1 by 2 outside, integral dx, plus 1 by 2 outside, integral cos 2x. If any constant is there, you can write outside, first rule. So this is nothing but x by 2 plus 1 by 2 as usual, and cos 2x integral just now we have done, that is sine 2x by 2. of course plus a c, integration constant. So x by 2 plus a sine 2x by 4 plus c. So if you have any confusion, again differentiate this, then you will get back to cos square x. So again if you do the differentiation of this answer, again you will get that function cos square x. I hope you understand. Okay. So let us take one more question. So please do it yourself. I have explained this, and second one try yourself, and let us take the third one. So third one, let us take this one. Here we have integral cos square x and sin square x, both are there, sin square x dx. Oh, cos square x into sin square x. So how to do this? Again we have to take the help of a trigonometric function. I think here we can write it as a cos x sin x whole square. So cos x sin x whole square, somewhere we have seen this. Sin 2x equal to 2 sin x cos x. But here 2 is missing. That's why let me divide with the 4 integral. Again 4, I hope you can write this as 2 sin x cos x whole square. That's better. So now 2 sin x cos x is nothing but, of course, 1 by 4 integral. This is a sin 2 theta or sin 2x, and square is there. Again earlier whatever the technique we have used, sin square theta 1 minus cos 2 theta by 2, cos square theta 1 plus cos 2 theta by 2. The same technique. So this is 1 by 4 integral. This is the sine, that's why 1 minus cos 2, 2 into 2, that is a 4x again, be careful, by 2 dx. Now first split it. This is 1 by 4 and 1 by 2, 1 by 8 integral dx. Again minus 1 by 8 integral cos 4x dx. Again cos 4x. What is a cos kx integral? You know that? That is a minus 1 by 8 integral, sine 4x by 4. This is a plus c, and this is x by 8. And you please check whether you got this answer or not. Again if you want to cross check, just go in the reverse way and differentiate this again, and you have to get this integrand. So just try, okay. Right. So let us take the next one. We have integral e raised to x dx. What is the differentiation of e raised to x? E raised to x only. So that's why antiderivative of e raised to x is also e raised to x. So that's why this is e raised to x, of course, plus a c. And sometimes if you have integral e raised to ax dx. So then same thing, e raised to ax by a plus a c. Okay, because if you again differentiate this, you have to get back to this integrand. If you differentiate the answer, you have to get the integrand. And for example, if you have a raised to x dx, a raised to x dx. So a raised to x dx is a raised to x by log x plus c. Okay, so if you differentiate this, one second, yeah, sorry. So a raised to x by log a raised to x by log a. You just take this function and differentiate it. Log a is a constant outside. A raised to x differentiation is a raised to x into log a. So that log a gets cancelled. So finally you will get again a raised to x. Next one, integral 1 by x dx. This is integral x power minus 1 dx. Earlier we have explained one formula, integral x power n dx is x power n plus 1 by n plus 1, but n should not be equal to minus 1. But here it is n equal to minus 1. So then this is log x plus c. This is frequently we will use this, don't forget. So integral e raised to x only, integral e raised to ax dx, e raised to ax by a, integral a power x dx is a power x by log a plus c, and integral 1 by x dx is log x. Now by using this formula, let us solve few questions. I hope you have copied this. Now let us take a few questions here. So the first one, first split it, that is integral 3, you can write 3 outside, constant 3 outside, integral e raised to x dx plus 5 outside, integral cos x dx. If you know already, you just pause the video and do it yourself and check the answers. Secant square x dx. Okay, so just now we have seen this is a 3, e raised to x integral e raised to x only. This is a 5, cos x integral sin x minus 10, secant square x integral, that is a tan x, plus some constant c, indefinite integral. We are finding a set of all antiderivatives. That's why we have to take a plus c. And the next one. Here also just split it, integral, you can write 2 outside, yeah, come on do it, secant x tan x dx plus 1 by 6 integral 1 by x dx. Here we have a secant x tan x, which is nothing but integral secant x tan x is a secant x plus 1 by 6, and integral log x, integral 1 by x is nothing but log x plus c. And the last one, try yourself, please try yourself, just pause the video and do it, be confident. So just split it, integral e raised to 5x dx plus integral 5 power x dx plus integral 1 by 5 constant outside and 1 by x dx. So we can write this e power 5x, that is e power 5x by 5 plus, and this is a power x integral is a power x by log a, there into log a, here by log a. So that is 5 power x by log 5 and plus this is 1 by 5, 1 by x integral is log x, of course. So indefinite integral, that's why we need to take the set of all antiderivatives, that's why we have to write a plus c. Please check your answers. Next, let us see these standard integrals. Integral 1 by 1 plus x square, 1 by 1 plus x square or x square plus 1. This is nothing but tan inverse x plus c. Sometimes if you have integral 1 by x square plus a square, so then this is 1 by a tan inverse x by a. Okay, and the next one. Here integral 1 by under root 1 minus x square dx. Here this is the sine inverse x plus c. But the same, we have one more answer here, minus cos inverse x plus c also possible. Or sometimes they will write this minus here. If you have plus, take sine inverse. If you have minus, you can take a cos inverse x. For example, if you have integral 1 over under root a square minus x square. If you have a square here, it is a sine inverse x by a or cos inverse x by, of course, minus cos inverse x by a. So let me write one more time. Okay. So here if you have integral 1 over under root a square minus x square dx, this can be written as sine inverse x by a plus c, and here this is minus cos inverse x by a plus c. So next here we have sin hx. Sin hx, in the differentiation of sin hx or cos hx, we don't have any, both are having plus. That means the differentiation of sin hx is cos hx and the differentiation of cos hx is sin hx. That's why here also we will get the plus only, cos hx, and here we will get sin hx. This answer I am writing here, sin hx. And the next secant h square x, same thing, here we have the tan hx, but unfortunately here differentiation of secant hx, we have minus secant hx tan hx. That's why here you will get minus secant hx. And cosecant h, this is as usual, minus cot h square x, and this is also minus cosecant hx. This is a small difference. Integral secant h, normal function, not hyperbolic, secant x tan x dx is a secant x only. But if it is a hyperbolic, we will be having a minus sign here. So please observe carefully and practice every formula 2-3 times. Please write on the rough paper and then proceed for the problems. So please practice all these formulae on a rough paper 2-3 times. Please write down each formula 5 times, write down, okay, and don't forget and don't neglect these things, please. Of course plus c will be there, integration constant I have not written, you please. Now here we have some problems. So just to split it as usual, integral this 3 outside constant 1 by under root 1 minus x square dx, and 6 outside integral sin x dx plus 10 outside integral sin hyperbolic x dx. So just now we have discussed, if a plus is there, please take a sin inverse x by 1. Here it is a square, that is a 1, plus 6, this is the sin x integral, that is a minus cos x, plus 10 sin hyperbolic, cos hyperbolic, both are plus only answers. So that's why cos hyperbolic x, plus c, of course. Please do it yourself, just pause the video and do it yourself, and after that check the answers. Now here again I am taking a 3 outside, just to split it, 1 by 1 plus x square dx, plus a 6 outside integral, this is a cosecant x cot x dx, and plus 9 outside integral 1 by x dx. So here this is the tan inverse 3 tan inverse x by a, of course here a is 1, that's why x only, plus 6, this is a cosecant x cot x. Cosecant x cot x integral is also minus, hyperbolic integral is also minus, that's why minus cosecant x plus 9 1 by x integral is log x. Whenever x power n, that is n equal to minus 1, then the answer is log x, of course, plus a c. Please check your answers. Please do it yourself, be confident, please do it yourself. Right, now let us see some integration techniques. So here the first one, integration by substitution. So here we are going to solve the integrations by using some substitution. So the similar thing we have done, in the differentiation we have done one chain rule. I hope if you remember, that is quite similar to this. That means in differentiations we have done a chain rule. That is, for example, d by dx of, you have u power n plus 1 by n plus 1. I want to differentiate this with respect to x. But here the function, here the variable is u. That's why our function, that means u power n plus 1 by n plus 1. So how you will write by using chain rule? This is the d by du, u power n plus 1 by n plus 1 into, this is the du by dx. This is what we have discussed in the chain rule. So this is nothing but differentiation of this function with respect to u. That's why n plus 1 u power n by n plus 1. n plus 1, n plus 1 gets cancelled. Once you differentiate this, you will get u power n into du by dx. That's good. So, finally we can say d by dx of u power n plus 1 by n plus 1 equal to u power n into du by dx. This is what we get. So let us take the antiderivative of this, that is nothing but the integration by substitution. So let us see, take a small problem, then you will understand what is this. Let me take one question first. 1 minute. So here I am taking integral x square plus 2x minus 5, x square plus 2x minus 5 whole square into x plus 1, something like this I have taken. So this is the integration. Now carefully observe. Integral x square plus 2x minus 5 whole square x plus 1. If you make it whole square and multiply x plus 1, then also we can do, but it takes so much time. So now what I am suggesting is, now carefully observe this function. Okay, so I am assuming, let this function x square plus 2x minus 5 equal to u. Just differentiate it. This is a 2x plus 2 implicit differentiation with respect to dx you have done. Of course, this is a constant 0 equal to du. So I think this can be written as 2 into x plus 1 dx equal to du. So this is the substitution. Now by using this, we can rewrite this integral as integral. This entire thing you have taken as a u, that's why u square, and this x plus 1 dx. If you carefully see in this substitution, x plus 1 dx is equal to du by 2. So that's why I can write it as a 1 by 2 du. So this integral we can do. So 1 by 2 outside, and integral u square du. U square du is nothing but u cube by 3. And you should not leave that. Again you have to substitute whatever the assumption you made, u equal to. So this is a 1 by 6 into x square plus 2x minus a 5 whole cube. Of course, plus a c something. Okay, it's okay. So this is the substitution method. That means whenever we have some function like this, we can assume it as u and just differentiate it and use this assumption and substitute and try to convert that integral, then it is very easy to solve. So let us take one more example. First please write down. So let us take a few more questions on this substitution method to understand more clearly. So here we have integral 2z dz by a cube root of z square plus 1. So I hope you understand. Let us suppose this will be the function. Let our substitution z square plus 1 equal to u, and just apply the implicit differentiation 2z dz equal to du. Now see, this is 2z dz equal to du. So finally integral, that numerator become du by, this is the cube root of this z square plus 1. That's why u power 1 by 3. So you can do that normal integration later. This can be written as integral u power minus 1 by 3 du. So I hope you can do this. Come on. And the next one here, integral under root 1 plus y square 2y. Please pause the video and try to do it yourself, and after that check the answers. And I can assume here this is let 1 plus y square equal to u. It's very simple. Just differentiate, implicit differentiation, 2y dy equal to du. Now please take it and substitute. Integral, this is the square root. That's why you can write u power 1 by 2. Okay, this 2y dy is nothing but du. So you know what to do this, how to do this. This is a u power, this is a 3 by 2 by 3 by 2. That's why a 2 by 3. So come on, do it yourself. And here also x square sine x cube. So let me take this x cube as some function. So let us suppose x cube equal to u, that implies if you do that implicit differentiation, 3x square dx equal to du. So of course don't worry, here we have x square dx. So x square dx is nothing but 1 by 3 du. So now please take this and substitute. Integral x square dx is 1/3 du, and this is the sine x cube is u and du. You know what is integral sine x? Integral sine x is minus cos x, and here this is a minus 1 by 3 cos u. Again you have to replace, you should not keep this answer in terms of u, that is 2 by 3. In this problem also we should not keep that answer in terms of u. Okay, here also we should not keep this in terms of u. Please write yourself, please do it. And here u is x cube. And here also this is 1 plus y square whole power 3 by 2. Come on, do it yourself, please do it yourself. So this is also, I think you got u power 2 by 3, and this is 3 by 2. And finally again you have to resubstitute whatever the assumption you made, that is a z square plus 1 whole power 2 by 3. So I hope everybody completed this. Now we can do this in a different way also. So here I will give you some more techniques. Now the first one, whenever you have integral, some function is there, that is f of x whole power n, some function power n, just like a sine square x or something e raised to 2x, something like that. So some function power x, some function power n, this is we are integrating. But here whatever the function you have, that differentiation is here, that means f dash of x. So integral f dash of x into f power n x. This is a simply very simple answer, f power n plus 1 of x by n plus 1. So earlier whatever we have done by using the substitution method, we can do all those problems by using this technique. Let us take one by one. So what is your first question? This first question is this one, integral x square plus 2x minus 5 whole square x plus 1 dx. Let us see. So once again, integral f dash of x into f of x power n, some power n is there. So that's simply f power n plus 1 x by, that is n plus 1. That means a function power n plus 1 by n plus 1. Let us take something like this, integral, earlier we have taken x square plus 2x minus 5 whole square into x plus 1 dx. This is what we have taken. Now listen please. Our rule is some f of x whole power n can be there, no problem. But a differentiation of this function must exist here. So what is the differentiation of this? X square differentiation is 2x plus 2x differentiation is 2. And if you take 2 common, then we are getting 2 into x plus 1. That is the differentiation. If you have any issue, so just strike a line and find the differentiation of this. X square plus 2x minus 5 differentiation is 2x plus 2. That's why I can take 2 into x plus 1. But we must have 2 into x plus 1. Unfortunately, here we don't have 2, no problem. Write 2 here. Of course, I will write this. Integral, again x square plus 2x minus 5 whole square. Here 2 is missing, that's why I am multiplying with 2. And again divide with 2. So, I hope you understand now. This is nothing but f of x whole square into f dash of x. So finally 1 by 2 as it is, as per this, our function whole power n plus 1. that is I'm sorry, the answer 1 by 2. What is the function? X square plus 2x minus 5 whole power 3 by 3. So if you check, you got the same answer. Now let us take one more example. The same earlier whatever you have taken, let us take the same thing. Second one. So our second problem earlier we have taken integral 2z dz by the cube root of z square plus 1. Now carefully listen. This cube root of z square plus 1 means that is, we can write it as, this is integral 2z and z square plus 1 whole power minus 1 by 3 dz. Our n should not be minus 1. It can be minus 1 by 3 or minus 1 by 2, no issue. It should not be minus 1. Okay. Now please check whether whether you have this differentiation of this function here or not. So let us take the differentiation. So this is my function. Z square plus 1 differentiation is nothing but 2z. Oh, absolutely it is there. So f dash of x, f power n. Simply f power n plus 1 by n plus 1. That is answer, direct answer. Z square plus 1 whole power n plus 1. That is minus 1 by 3 plus 1 by minus 1 by 3 plus 1. So that is z square plus 1 whole power 2 by 3 into, that is 3 by 2. Same answer. So let us take the third one also. That is, we have third one integral under root 1 plus y square 2y dy. So I hope now you understand. Please do it yourself. And this is my function and I want to cross check whether I have that differentiation or not. 1 plus y square differentiation is 2y. Yes, absolutely I have that differentiation. So f dash of x, this can be written as integral 2y 1 plus y square whole power 1 by 2 dy. So this is f dash of x, f power half, f power n. The direct answer, f power n plus 1 by n plus 1. That's why 1 plus y square whole power 3 by 2 into 2 by 3. Is that clear? Let us take a few more examples on this. Please write down. Don't simply copy, try to do it yourself. Please pause the video and try to do it yourself. First question, please observe carefully and after that try to do it yourself. Now let us take a few more examples on this. Just pause the video and do it. And next I am taking like this. We have a fourth question, integral sine cube x into cos x dx. Let us suppose. Now carefully observe, this is a whole power is there and some function is there. You have to cross check whether do you have differentiation of this function. Yes, the sine x differentiation is cos x. Yeah, it's there. That's why it's simply this is f power nx into f dash of x. Integral, one more time I'm writing, f power nx into f dash of x dx. What is the answer? This is simply f power n plus 1 by n plus 1. Your function is a sine here, n is a 3. That's why answer sine power 4 x by a 4. Of course, at the indefinite integrals there will be some constant. Let us take one more. So here we have integral cos square x into sin x dx, let us suppose. Okay, so let us check whether do you have this differentiation or not. Here this is our function. Cos x differentiation, here we have minus sin x. But unfortunately there is a sin x, no problem. Just write minus 1 here. Okay, so let me keep the question as it is, otherwise you don't know what is the question. So integral cos square x, I am taking one minus extra and again one more minus here. Okay, then problem is solved. So this is f power n into f dash, f power n into f dash of x. The answer is simply, this is f power n plus 1, that is a cos cube x by 3. So like this we can do, that is integral f dash of x into f power n is simply f power n plus 1 by n plus 1. Please practice all these things and don't neglect. So very crucial for our CSIR coaching. So please practice all these things. Right. Now let us introduce another one. This is the second technique. Whenever you have integral, okay, so in the numerator we have f dash of x, that means the derivative of f of x. In the denominator we have 2 into root f of x, something like this. Just observation, nothing else. So in the denominator you have 2 root f of x. If 2 is not there, you will get this 2 in the answer, that's okay. 2 root f of x is there in the denominator, and the numerator contains the differentiation of this function, that is f dash of x. It's a simple answer is root f of x. So no need to substitute anything. So let us take one more time. So repeat, integral f dash of x by, take care of paper, please write 5 times 10 times. Integral f dash of x by 2 root f of x dx is root f of x. Now see this one, and here you have a root function, very good, okay. So don't worry about this whether 2 is there or not, please first proceed. Now take this function and take its derivative and check whether it is there in the numerator or not. 1 minus x square is my function and I am taking its derivative, that is a minus 2x. Oh, unfortunately x is there in the numerator, but minus 2 is not there. That's why I am going to rewrite this. Denominator as usual, under root 1 minus x square, already x is there. That's why I am multiplying with minus 2, because I can multiply and divide with a constant, no issue. So that's why I want minus 2, and here also I am dividing with minus 2, minus outside and 2 here. Then your problem is solved. So this is nothing but integral f dash of x by, this is nothing but f dash of x, and this is nothing but 2 root f of x. So answer is simply root f of x. That's why this is under root 1 minus x square. Okay, so still one more question will take, one more question I will explain. The next one at least do it yourself. Now see this, integral m naught v dv by under root 1 minus v square by c square. Don't take tension, first take the function. Okay, so take the function, just check the derivative. 1 minus v square by c square derivative is simply minus 2v by c square, because it's a constant. A constant we have to neglect only whenever it is in the addition or subtraction. Whenever it is in the quotient or that is the coefficient, we should not neglect that. So you have to keep that constant as it is. So this must be there in the numerator. Now let us check. Do you have? Oh, I have only v, no problem. What is not there? Minus 2 by c square. Just multiply with minus 2 by c square and again divide with minus 2 by c square. Now see, I am rewriting. So I am writing m outside, m not outside, because I don't want. So v by under root 1 minus v square by c square. Unnecessarily don't worry about that 2. Okay, so just proceed. What is missing? Minus 2 by c square is missing. I have written. So in the denominator also you have to write the same thing, minus 2 by c square. In the denominator also you have to write it as a minus 2 by c square. So as per the formula I want only 2 in the denominator. So the remaining thing I am bringing it outside. That is a minus m naught. The c square will come into the numerator. Integral minus 2 by c square into v by under root, of course, 2 into 1 minus v square by c square dv. F dash of x by 2 root f of x is simply root f of x. So minus m naught c square under root 1 minus v square by c square. Okay. Now can you please try the third one yourself? Please try. Just pause the video and try to do it yourself and then check the answer. Please. Now here I am taking this function, that is 1 minus 6x differentiation is simply a minus 6. Okay, so here we have 6 but minus 6 is not there, so no problem. Integral whatever you want, please write down minus 6 by under root 1 minus 6x. So no need to worry. Sir, here 2 is not there, you just multiply. So 1 minus extra you have written, that's why I am writing minus outside, and 2 is not there, that's why I am writing 2, and here one more 2 I am writing. Okay, so that's it. So this is minus outside, and if you observe carefully, this is f dash of x by 2 root f of x. F dash of x by, I'm sorry, 1 minute, 1 second. Yeah, correct only, but we should not write 2 here, that's a mistake. Okay, we should not write 2 there, and we have to write 2 outside, then there is no issue. So here it is f dash of x by 2 root f of x, which is nothing but root f of x, minus 2 under root 1 minus 6x. This is what I told you. If this 2 is not there, 2 will come here, that's it, no need to worry about that. So integral f dash of x by 2 root f of x is equal to root f of x. If 2 is not there in the denominator, the 2 will come here. So this is the most important formula. Please remember and practice 3-4 times. Please write on rough papers, don't neglect. So next we will take one more technique, that is third one. For example, here we have integral some e raised to f of x is there, e raised to f of x, into you have the differentiation of that function, that is f dash of x dx. So this is simply, answer is e raised to f of x only, because you know what is e raised to f of x differentiation. E raised to f of x differentiation is e raised to f of x into f dash of x, reverse. So integral e raised to f of x f dash of x is nothing but e raised to f of x. Of course, plus a c will be there, okay. Now let us take a few more examples here. So here I am taking integral cos x e raised to sin x dx. You can do this, please, come on, continue. So here we have, this is the function f of x and its differentiation is here. That's why simply answer is e raised to sin x. Of course, plus c. And the second one we have here integral x square e raised to x cube dx. Now this is your function, and your function differentiation, x cube differentiation is 3x square, but 3 is missing, so no need to worry, just write 3 here, x square e raised to x cube dx. And you have written 3 extra, just compensate that, 1 by 3. So this is nothing but 1 by 3. So here e raised to f of x, so answer is e raised to f of x. Next one, third, yeah, please do it yourself, just pause the video and do it yourself. Z e raised to I z square dz. Let us take this, just pause the video and do it and then check the answers. So here this is your f of x, its differentiation is 2iz, iota, this is iota, 2iz. So here 2 is not there, iota is not there, so no problem, both are constants, you can write integral. I am multiplying with 2 iota z as usual, e raised to iota z square dz. I have written this one as an extra, okay, just pay the compensation, 1 by 2i. and this is nothing but f dash of x into e raised to f of x, which is nothing but e raised to f of x. So 1 over 2i e raised to iota z square. And let us take the another one, fourth also, integral, please do this, sin x. So this is e raised to cos x dx. So here we have e raised to f of x, that f of x is a cos x. Cos x differentiation is minus sin x, but unfortunately minus is not there, no issue. First write whatever you want, but it should be a constant. You cannot write a variable, okay, it should be a constant. Minus sin x e raised to cos x dx. But you have written minus extra, that's why one more minus outside. So this is nothing but minus e raised to cos x. If you want to cross check, again differentiate this and you will get back to the integrand. Again if you differentiate, again you will get back to the integrand, because I told you this integrand is the antiderivative of that. This integrand is the antiderivative of that. That's why again if you derivative, I mean if you find the derivative of that, you will get back to the integrand. So come and do it. And let us take the last one. I hope you have completed. And the last technique, please do it yourself, don't neglect, please learn. And now the last fourth technique, today in this last technique. So here we have, let us suppose, integral. In the denominator we have f of x, and the numerator we have f dash of x, it's a derivative. Okay, so whenever you have this situation, the answer is simply log f of x. The reason is, just take the log f of x. I told you, this is the antiderivative of this function. So this is the antiderivative of this function. So again derivative, just apply the derivative. Then differentiation of log f of x, 1 by f of x into f dash of x. So based on this, let us take a few more questions here. First one, integral e raised to x by 1 plus e raised to x dx. Of course, we are solving these integrals in the well-defined domain only. Okay, we are not going for any undefined functions. Okay, please remember that. Okay, so here this is my f of x and it's a derivative. First you have to check it's a derivative. So 1 plus e raised to x derivative is simply e raised to x. Yeah, it's present in the numerator. That's why answer log of 1 plus e raised to x. Next question. So let us take integral sin x by 2 plus 5 cos x, something like this. Now please observe carefully. This is your denominator f of x. Do you have the derivative of this function in the numerator? The derivative of this function, please write down if you are having any trouble. So 2 plus 5 cos x derivative, just check, its derivative is minus 5 sin x. That's it. So of course minus 5 is missing, no problem. So just write minus 5 sin x by, this is 2 plus 5 cos x, and pay the compensation, whatever you have written extra, that minus 5, just divide with again minus 5. So this entire thing is nothing but f dash of x by f of x, which is minus 1 by 5 log of 2 plus 5 cos x. Okay, and one more let us take. So please pause the video and try to do it yourself. And here we have, this is x dx by x square plus a square. Let us suppose x dx by x square plus a square. Okay, so same as usual. This is my function. So x square plus a square derivative is simply 2x. But unfortunately in the numerator I have only x, no problem. First, write whatever you want if it is a constant. The required one is a constant, you can write happily. That is 2 I want, x square plus a square dx. But you have written 2 extra, that's why just to pay the compensation. So this is nothing but 1 by 2 and log denominator, that is log of x square plus a square. And you can write this as a root, log of root x square plus a square also. I hope you know that. And like this we can continue. Okay, we can do by using this formula. So here today I have explained a few techniques. And what is that? First one, substitution method, and after that we have given integral f dash of x f power n is simply f power n plus 1 by n plus 1. Next one, integral f dash of x by 2 root f of x is a root f of x. And the next one, integral f dash of x e raised to f of x is e raised to f of x. And the last and final, integral f dash of x into 1 by f of x, 1 by f of f dash of x by f of x dx is simply log f of x. So please practice all these things. In the next lecture we will discuss some more techniques, beautiful techniques about this integrations. Okay, so thank you, and we will meet again in the next lecture. And please practice the assignment properly. So please practice that, and we have given the PDF file also. If you don't want to write the exam, first practice the material, and after that finally please go for the exam. Okay, so I request you, don't neglect, please don't neglect. Thank you.